Hello friends, in our last video we discussed about the discovery of electrons. In this video we will proceed a little bit further and we will discuss about the discovery of protons and neutrons. Well, we saw that the very first step we took towards the discovery of the electron, and the most important of the ones, was the cathode ray tube experiment. Well, the cathode ray tube experiments, the cathode ray tube experiment was modified. Okay, it was modified to give a stream of positive. Remember, the cathode rays were negative. Here in this case, it was modified to give a stream of positively charged rays called as, they were called as canal rays. Okay, they are called as canal rays. Okay, so the cathode ray tube experiment, it was modified not a little bit but very much to give a stream of positively charged rays. Those are known as canal rays, and after studying those type of rays, several conclusions were derived which was very much different from that of the conclusions which we derived for the cathode ray tube experiment. Okay, the conclusions which were derived was that these positively charged particles, it depended. Okay, these, first of all, let's see that what was the basic difference. The basic difference was that the positively charged particles were very much heavier than those of negatively charged particles. Negatively charged particles. Okay, this was the very first difference and one of the most important ones. And the other conclusion was that unlike the negatively charged particles, E by M is charge by M. Do not confuse it with the charge of that of an electron. Okay, well, the E by M ratio, that is E by M of positively charged particles, depended on the type of gas used in the tube. Okay, so these were the two main conclusions that were derived from this particular experiment. Okay, so from here we can say that unlike cathode rays, these positively charged particles, they depended on the nature of gas that was used. Okay, since we can see that E by M ratio, the charge to mass ratio of these positively charged particles are different for different types of gases used. Therefore, we can say that its characteristics and its other properties also depended on the type of the gas that we used for this particular experiment. Okay, and another conclusion was that, one more conclusion that was given was that their behavior, that their behavior under electric and magnetic field was entirely different from that of the negatively charged particles. Negatively charged particles. Okay? So their behavior under electric and magnetic field was entirely different from that of the negatively charged particles. So this tells us that obviously that since the charged particles are positive, that is opposite to that of the negatively charged particles, so their behavior is their behavior ought to be different, and particularly this observation led to the conclusion that they are positively charged particles. Okay, so from here, from these experiments, protons were discovered. Protons were discovered. Okay, from these experiments, protons were discovered, and later on, neutrons were discovered as well to compensate for the difference in the observed masses of the elements than that of the theoretical. I mean to say that the theoretical masses of the elements were different from that what we observed from different types of experiments that were carried on them. So therefore, in order to compensate for that, later neutrons were discovered. Neutrons have no charge. Okay, so they are electrically neutral. They do not move either towards anode or towards cathode under the influence of a voltage. Okay, they are very heavy. Very heavy. They are heavier than that of electrons and that of protons. Well, the charge of the mass of neutron is slightly greater than that of proton, but it is very, very greater than that of electron. Okay, so let's see what types of models were first put forward by different scientists to study, or to be more precise, who tried to study the structure of any atom. The very first model was given by J.J. Thomson. It was given by J.J. Thomson. We also call it as the apple pie model or the pudding model. Anyways, the model, it says that an atom is a circular something which is entirely of positively charged. An atom is of circular shape which is of positively charged. It is made up of positively charged particles. Positively charged particles. Okay? And inside it, the electrons are embedded, just like the seeds in a watermelon, like this. These are electrons. Okay? So obviously this model was later on discarded. This particular model was later on discarded, and Rutherford performed an experiment using gold foil. After this model, Rutherford performed an experiment. Rutherford's gold foil experiment. Okay, gold foil experiment. This model was given by Rutherford. Okay, so in this experiment, what he did was that he passed a beam of alpha particles. He passed it through gold foil. Okay, he passed it through this. This is gold foil. Okay, and this gold foil was surrounded by some fluorescent material made up of zinc sulfide. Okay, this was surrounded by this fluorescent material. Okay, now what used to happen is that alpha particles, beam of alpha particles used to strike this gold foil, and after striking the gold foil, the alpha particles which passed through it used to strike this fluorescent material at some points. Okay, used to strike these fluorescent materials at some point. So therefore, after observing all this, after reading all this, he observed that after this experiment, the observations was that most of the alpha particles. Now I'm rubbing this particular setup. He observed that most of the alpha particles passed undeflected. Okay, so from this model, or from this observation, he came to a conclusion that most of the space inside an atom is empty. Okay, most of the space inside an atom is empty. The another was that the small fraction of alpha particles was deflected by small angles. Okay, another was that small fraction of alpha particles was deflected by small angles. Okay, so from here, and also there was one more in which he observed that very few alpha particles got reflected by 180 degree or closer. Okay, so from these two observations, he came to a conclusion that actually nucleus is a very small space inside an atom. A nucleus is a very, very small space inside an atom. I must say that a nucleus, if experimentally, if practically, if I try to make you understand, then suppose, or that suppose if I revolve this, that suppose this is a football field or a cricket field, okay? Suppose this is a cricket field and this dot is there. I hope you can see it. Suppose this is a cricket field and this dot is there inside it. Then this complete cricket field is the atom, and this dot is the nucleus. In fact, even the smaller than this dot is the nucleus. Okay. So these were the observations of the Rutherford's model. So that's all for this video. In the next video, we will discuss what were the conclusions finally on which the Rutherford models arrived, and also we'll start with the Bohr model. So thank you.